All right, good morning, everyone, and welcome to today's webinar, How the Rhode Island Department of Transportation Reduced Wrong-Way Driving with Wrong-Way Alert Systems. Thank you for joining us today. I am Marissa Ray, TAPCO's Marketing Event Specialist, and I'll be moderating today's discussion. Before we get started, a few housekeeping items to go over. All participants will be muted during the webinar to eliminate any background noise and feedback issues. You will see in the right-hand side bar that there is chat functionality. We encourage you to leave questions and comments there throughout the webinar. There will be a Q&A session to close out the webinar where I will pose these questions to today's presenters. And we will be distributing a copy of this presentation to all attendees. All right, for those of you who are not aware, TAPCO is based out of the greater Milwaukee area. We are a third-generation, family-owned company driven to increase road safety for all users. To do this, we focus on 4 core strengths: innovation, quality, service, and expertise. Today, we are focused on our expertise as a wrong-way system alert system provider with over 65 years of keeping roadways safer. Alrighty, and now to introduce our presenters. Our first expert today is Russell Holt. Russell is a principal civil engineer with the Rhode Island Department of Transportation, assigned to the Highway and Bridge Maintenance Division's Transportation Management Center in Providence. Since starting work at the Rhode Island DOT in 2003, he has been responsible for managing and reviewing projects and efforts to improve traffic safety and operations on Rhode Island's roadways. Some recent initiatives that Russ has been integral to include the preparation of a new Rhode Island DOT message display policy for changeable message signs and the development of a transportation systems management and operations performance measurement plan for both the state's DOT and MPO. Prior to joining the Rhode Island DOT, Russ worked as a research assistant at the Virginia DOT Smart Travel Laboratory in Charlottesville, where he studied the reliability of estimating motorist travel times on Interstate Route 66. Russ graduated from Clarkson University in New York in 2001 and the University of Virginia in 2003 with Bachelor of Master in Science and Civil Engineering degrees, respectively. He served as a president of the Rhode Island ITE chapter from 2009 to 2010. Russ is a registered professional engineer in Rhode Island. Our second expert is Nick Schmidling. Nick has been with TAPCO for several years as a senior product manager. Many of you may have seen him at various conferences, trade shows, and industry events. Nick is an expert in overheight warning systems, as well as dynamic curve warning systems, wrong-way driver solutions, intersection conflict warning systems, and LED enhanced signage. So without further delay, I will go ahead and hand it over to Russ.
Okay, Marissa, thank you very much. Can you hear me all right?
Yes, I can. Thank you.
Okay, great. I'm going to share my screen.
All right, perfect.
You guys can see it just fine. Okay. Marissa, does that look okay? I'm loading the full slideshow.
Yes. Yep,
okay.
Looks good. Thank you.
Great. So, all
much,
right. Thank you very much. I appreciate the time today. Marissa, you used the word expert. I don't think that's fair. I don't think that's accurate for me, but I appreciate it anyways. Basically, yes, so I want to take a few minutes to talk about where RIDOT came from with our systems, why we chose to deploy them a few years back, where we are now, what our systems look like, and where we want to go in the future. I have a little time to talk. I'm from New England, so I talk fast. I apologize for that, but I decided to include a little more information in my slides than less, just in case somebody sees it and it helps you in any way. So you'll be able to get the slides after the presentation or ask questions. So I apologize if I talk too fast. But anyway, so wrong way driving, for now, it's a reality. No matter where you work, worldwide, really, all the DOTs in the country have a lot of challenges with this. It's a reality because you got asphalt or concrete pavement, and if human beings are driving cars, mistakes can happen, and they will happen. And so it's a big challenge for DOT. It's not just one challenge, but it's multiple, faceted. One is, the big challenge is when wrong way drivers crashes happen, especially on freeways, usually the outcome's just terrible. It's just tragic, and lives are too frequently lost. So that makes it a huge issue for us. The next one is older, distracted, and impaired drivers. Can you honestly say that any of those type of drivers are decreasing in your area where you work? Probably not. I think people are getting older generally. Distractions, it's a big issue with cell phones and things. And then impaired drivers, despite the best efforts of DOTs with soft side programs to curb impaired driving, it's still a huge issue. And it's too high of an issue. It's unacceptable. So those numbers are going up. Also, wrong way driving can happen almost anywhere, anytime. As I said, you got slabs of pavement and vehicles operating. I call them deadly weapons, really, is what they are. They can be. And, so if you can cross over a yellow line, which is not a formal barrier of any kind, you're going to have that risk. At many locations, geometric improvements just aren't feasible. You might say, Russ, well, why not put a barrier up or something? Well, it's common sense that you can't always do that. You might have right-of-way issues. The image I show at the right is a semi-rural location in Rhode Island, but some locations you're urban. You can't take any right-of-way to change your geometry. So that's not always an issue. And then finally, this is the one that's overlooked sometimes, is the violations themselves. DOTs like us, we don't know everything. Believe it or not, you might do a crash study after the fact, and sure, you'll show a crash report that shows somebody was going the wrong way on 95, but that's way too late. Weeks later, months later, you get the report to take action in real time to try to stop that violator. And save lives. And even then, in many cases, people will turn around and correct on a ramp from a wrong way sign. Oh, I'm going the wrong way. Does DOT ever know about that? The answer is no. Unless you have a camera or an eye there to see it, you're probably not going to know. So the challenges are many. And in Rhode Island, we had, over the years, just like you, wherever you work in the country, it's an issue for you. The wrong way drivers cause major problems, and we lose lives. It's just tragic. So thankfully in Rhode Island, I was not one of the folks involved with this project. I don't want to take credit for it, but we had some safety leaders, some state officials and executive officials who said, kind of enough is enough. And we're a towards zero death state. We believe that, just I'm sure your state does too, any death is just unacceptable. And what can we do from an engineering perspective, from an enforcement perspective, soft side perspective, whatever, what can we do to curb that? It's important to do that. So thankfully in Rhode Island, we did that. And it was about 2014 where we did a study to try to identify where, when, and why the wrong way crashes are happening. Not surprisingly, we found that approximately 80% were in the Providence metro area. That's where most of our travel demand is and the traffic is. Never mind a lot of the drinking establishments and things like that. And then approximately every 2 of every 3 wrong way incidents was occurring between 11 p.m. and 5 a.m. Also not surprising. I want to thank the VHB team. They had leaders who helped us develop this and study this and push this. So those guys were excellent with us, advancing these systems for us. They also looked at citations. Where are police citing people for going the wrong way? Again, thankfully no crash, but still, if there's a high risk location, that can be tracked by looking at your citations. And finally, really probably the most important thing before we looked at the intelligent systems from TAPCO is the let's call it easy peasy, old school traffic control signage and markings. We did an inventory of our limited access ramp locations across the state to look for where, are we meeting the minimums for the MUTCD, or should we supplement them with additional signs and things? So we did that in 2014-15. The first easy solution was to make sure that our signs met the minimums, obviously, but also exceeded the minimums in several cases. So we lower the signs, use the retroflective strips on the posts, as you can see here. So I mentioned that just because in case you're looking at advancing wrong way driving intelligence systems now, you might want to make sure first that your signing systems and markings are meeting the minimums as a first shot. So we looked at the intelligence side of things, which is why you're here today, is to learn about this. So we did advance 24 pilot locations with the state police's help and input. All our locations that we piloted the systems at were limited access locations. So there's no like downtown one-way circulator locations where we put the system in, although we may have been able to do that. There is one special case. On the right, you can see, sorry, it's small, but in this case, this is an I-95 is going north-south. The the blue sign on the farthest right blue sign, that's the wrong way driving system we first put in. It's as cars approach from Route 1A on the right side of the diagram, people will approach the two off ramps to 95 north and south. We figured putting the sign there, the smart system there, would curb and stop, hopefully all the folks catch all the people using those wrong way ramps. But we later learned there's some challenges there, just given the geometry. It's so poor there, in my word. But we put additional signs in afterwards. The two you see on the ramps were put in afterwards. And I'll talk about more about that special case in a minute. But the key functionality we decided in our system was we wanted a turnkey system, meaning we didn't have any ATMS or Advanced Transportation Management System to integrate with from the get-go. This was 2014, 2015. We wanted a turnkey system. We wanted a provider who can provide the whole system to us at each site and to provide us with the following things. One was we wanted to use a flashing sign of some type or beacons of some kind to wrong way drivers to tell them that they're going the wrong way on a ramp. We also wanted the email or text messages to go to the RIDOT TMC where I work and the affiliated police agencies who are associated with this particular ramp. We wanted those notifications to be made. And also to have a web-based application to monitor this and manage this stuff. And we also wanted the ability to use changeable message signs to right-way drivers and give them a message, warning, wrong-way driver in the area, use caution or whatever. That's some of the key functionality. Another piece of functionality I didn't mention here, I should say, is to have an image of the offending vehicle. So you'd have a camera of some kind to take a photo of the wrong-way driver. And that can help with enforcement and investigation and all sorts of things. So procurement and implementation in 2014, we did the pilot project. Again, 24 locations. You may be curious, we used Highway Safety Improvement Program funding to get this project done. And the key thing, the third bullet there, is we made it a requirement to TAPCO, particularly TAPCO's BlinkLink web monitoring service. Why did we do that? Well, in 2014, I'm pretty sure all the design team could find was they were the only one offering such a robust system at the time. There may be other competitors out there that Nick and his team have now who offer similar services, but at the time, TAPCO's was the only one that we saw was up to snuff there. So we made that a sole source requirement. Since then, we've had only 5 additional locations across the state that we've added. We've done that via separate contracts and agreements. More are planned. I'll talk about that at the end. But we've had to make some improvements, some adjustments to our original designs. As with any design, you learn from your first deployment. This was the 24 original ones were a pilot after all, and we had some issues which I'll talk about in a minute. Real quickly, the system components. These are older drawings. Showing that basically you got a pole with a cabinet and a controller in there, the smart controller, in this case from TAPCO, to discern, what the detectors are seeing. In this case, we had microwave radar detectors we originally called for on a pole to get the speed of the vehicle and, identify when there's a wrong way vehicle on the ramp. The camera and a light emitting source there, just above that, is there to take those camera images that I mentioned to document the vehicle. See the vehicle. And solar panels, those are an option from somebody like TAPCO, but we used them originally thinking that let's keep it off the grid and make it easier, get it in faster, and hopefully lesser overall cost is to use solar power. And we've had some issues with those, but again, you can see the option there is to use panels like that. The top right skewed image there is just, we call it like a slave pole. We originally called it that. That's any pole where you have the integrated flashing sign and it's communicating back, with the master pole where the cabinet and controller is. So there's just radio equipment there to make that communication happen. So the latest system components that TAPCO would show you, Nick may show it later. Pay attention on this slide to number 1 and number 3. Number 1 is the latest sensors and detectors that I think TAPCO is supporting and recommending is the Teledyne FLIR units. They're infrared detection units rather than radar. So that's shown here. And then number 3 is the cameras. You can see this is just like kind of a example image from TAPCO, but TAPCO's got some pretty cool latest, I think they're Axis product cameras that can be used. We all know the technology is really advanced on those cameras. So the things that are available now versus 2014 are just kind of mind-boggling to me. There are some newer technologies that can help your systems if you're going to look at deploying one of these soon. This image is also from TAPCO. It's intended to just show generally how the system works. I apologize to Nick and Marissa. This is an older image from a few years back. But one key thing for you to take away is, don't mean to be confusing here. This image shows 4 poles. At Rhode Island's 24 pilot locations, most of them only use 2. So there's options here for you. You can decide locally, if you're looking at advancing these systems, do you need just 2 poles or do you want 4 or even more? One of our systems has, I think it's 8 poles or 6 or 7 poles, whatever it is, for one of our more complex locations with multiple off-ramps coming into one location. But the vast majority of our systems just have 2 poles. And with an alert activation zone upstream, the radar or FLIR unit is going to see that wrong way vehicle and then send the messages via remote cell modem to the BlinkLink server somewhere, wherever TAPCO hosts it, somewhere in the cloud, and then make appropriate notifications. If the person doesn't self-correct in that correction zone you see on the screen, then obviously the images will be camera images will be taken to show that that person proceeded, and then the agencies like mine or the police can take appropriate action. So this screen, real quick, Nick has a similar screen he's going to show. So I'll just show briefly that on the far left is what RIDOT went with so far. Again, I mentioned turnkey systems. We went with turnkey because we didn't have things on the right, such as a reliable high-speed fiber network that we already had to all our ramps that we knew we could trust. We also didn't have an ATMS in our TMC. Again, that's an advanced transportation management system that arguably should integrate with all sorts of ITS in the field. We didn't have any such thing yet. So we decided to go with the left side option. The good news is TAPCO offers you all these options, and you can choose the one that makes sense for you. But we wanted the turnkey, so the cell modems are all supplied by TAPCO, and all the radios, everything's supplied basically by TAPCO. Real quick design and installation considerations. Every site is unique. There are power issues. That's what I mentioned before. Some of our solar panels, maybe who knows, maybe the panel itself or the batteries were too small, or maybe we just had foliage and stuff that got in the way. Or finally, we're a New England state. We have a lot of lack of sun in the winter. Like right now, this is January. This is a bad time for us with some of our systems occasionally going down because they lose power. And I would say that's a design issue, that you get a good designer when you design your systems, and you can certainly, I think, cut that off at the pass early on in design. Also, false positives. I want to mention that I have some screens to show in a second about why we're getting some of those and how TAPCO is helping us improve those. But it is a reality. I'm an engineer, so after all, I'm a rational guy. I wanted to share that. I don't want to say that these are perfect systems. You got to design them correctly and make sure your contractor installs things correctly. So with that, we currently have 29 sites around Rhode Island. Most of these are still in Providence metro area. None of these I would consider ultra rural locations, but these are the systems we have. And next few shots show some screen grabs I've taken from the BlinkLink software. If you haven't seen it yet, Nick's going to go into detail in a minute on this, but it's really cool. Basically, this first example is what I would call, quote unquote, like the perfect case. This person was coming 2:26:25 a.m. on Christmas morning. So I would argue maybe only Santa Claus should have been out at that time, but this person was on the road. They're coming down the ramp. You can see this is one of our bigger ramps on 95. And thankfully, he or she turns around. And it's great. The images from TAPCO catch that. You can see the person turning around. These signs have been activated by that point. I should say we used the BlinkLink signs from TAPCO. We didn't use separate beacons or anything. Our LED red lights are flashing in the signs. And so this person turned around. It's exactly what you want to see. Just pay attention to the kind of the event logs and the details you get in the BlinkLink software. And I've highlighted the resolution that our operators, somebody here typed in seconds later, okay, this was self-corrected, and that's tracked that way and then saved for further reporting. So this was a best case example. I am going to go through the protocols before I end here on the protocols of what RIDOT uses to as these alerts come in. So I'll cover that in a second. This screen shows some flexibility of the system, how BlinkLink allows, if there's an emergency response vehicle. You might say somebody's going the right, wait a minute, Russ, we have a construction project. Somebody's going the right way, but it's not a, quote, problem, right? Well, the system's smart enough to handle that. We've got emergency response vehicle or maintenance vehicle that can be entered into the system as a resolution. In this case, there was a crash, I think, and the police had closed off the ramp on the other end. And so you can see the tow operator trying to get down there to remove a vehicle. So that was a good case. This is another good case where a person turned around. This is the infamous Thurber's location. The Rhode Islanders up here know this location is infamous. Why? Because this is our highest wrong way driving site of all of them. we get a high percentage of people at this site going the wrong way. A couple reasons for it. It's hard to see in the images, but this is like, it's almost like a surface street. Remember that image I showed you a few moments ago? This is like, it's like a surface street. It's not a freeway facility where this black car is, but it's approaching those two ramps. And so the system was first put in here, and again, it's helping things. The person turned around, but the reason I highlight it now is in red and yellow in the box I've highlighted here. A key thing you might note is the resolution. The notes say the person turned around before 95. Great, one of our operators typed that in. However, look at the resolution. Was it updated to say wrong way vehicle, self-corrected? No, it wasn't. So when we look at reporting after the fact, that can be a challenge. So I'm just mentioning that the recommendation is to make sure when you're deploying or setting up your systems, don't feel bashful about setting protocols for how your operators using these systems are supposed to close things out and report things. That can be important. Real quick on the false positives, very quick, I'll just show. So we've gotten false positives, I think mainly at a few of our radar locations around the state. And I found that those lift arms, not lift arm, it's a cover for the bed of the truck, is what I found to be flagging, setting off these false alerts. You can see it in a couple of the images here, but also it's like almost any non-linear, load in a flatbed or something like that tends to set off some of our radar detectors to say it's an alert. So the good news is, again, BlinkLink, and you got trained operators here, they can say it's a false positive, right? No harm, no worry. I even got one of our maintenance officials saying, Russ, I actually am happy to have a false positive. It's better than having no system, right? You would argue. So that's true. However, the false positives, they can be a little bit of a cry wolf problem. And so we're working with TAPCO. TAPCO is working with us right now to avoid some of these issues where we still get them. I still believe it's mainly the detection technology, some of the radar that's there. It just wasn't robust enough at the time to avoid them. So I think the FLIR units are much more promising on these, but I do want to mention it. So real quick on the safety performance, this is really the main thing. What's RIDOT experiencing from these systems? Well, we're pretty pleased because in our limited expertise in checking crash data, it's not a perfect science with wrong ways, because you can't always track where they're coming from, where they're going. And if there's no crash, it's hard to know, where they ended up. You might follow me. But bottom line, this screen shows that we get the pre-activation on the left before we put these smart systems in, and then after. And so clearly the fatalities have gone to 0, which is great. If you're a safety engineer, you know that, Russ, take that with a grain of salt because there's some randomness to that. But it's a fact. This is a fact. The numbers don't lie. We haven't had any more fatalities, and the crashes have gone way down. Those are huge. As I said at the top, these crashes result in too often severe impacts and fatalities, severe injuries, things like that. It should be unacceptable to DOTs, and I know it is. So these are good results. The flashing signs, this is telling me that the flashing sign component of the systems are decreasing the time that those wrong way drivers realize, oh crap, I'm going the wrong way, and maybe I need to turn around here. So it's not a panacea, but it's definitely helping. Real quickly too, on system reporting, the BlinkLink software can do a lot of things for you. And I was asked to show what are some of the things RIDOT's doing with it. So there's some questions we can answer that we couldn't before. For example, what % of violators are self-correcting basically on the ramp or right in the vicinity of the ramp? Well, with the system, you can pretty much tell that in most cases. And so then here's some numbers from recent months. About 90% self-corrected. 10 or 11% went through. Is that disconcerting to you? It should be. So not everybody's stopping and turning around. That is a concern. And I'll get into that in a minute here. But the fact is, look, you can get numbers on this. Without the systems, you can't do any of that. And then what times a day are they being reported? This isn't surprising. This is in line with VHB's findings. Most of them are 11 o'clock to 3 a.m. I went a little further and looked at some data for what about the folks that are going the wrong way? When does that happen? What days and what times? Well, this one was interesting to me because on the far right, you can see I expected it to be, 75% Saturday, Sunday night, overnight, early. Well, it wasn't. I'm seeing some high percentages Monday, Tuesday, Thursday, early morning hours. Now, sure, you might say, wait a minute, Russ, look, this is October 10th to January 10th. Just recently, you had the holidays, right, Russ? Well, we did, but remember, I'm pretty sure Christmas and New Year's were Saturday this year. So these numbers are eye-opening to me, and the point is just that you can run such numbers with the software, which is pretty neat. Real quickly on system reporting and a big part of the system reporting is the equipment status and the condition of things. So if you're a maintenance type personnel are the ones who can benefit from the system? I would say they sure can, because now you can remotely, if your comm's working, which is pretty reliable with these cell modems, we found that you get your battery voltages, your temperatures. If you've lost connection to a camera and a controller in the field, you'll get a automated text alert or an email inside from BlinkLink, from the software, which is really cool for our maintenance personnel. Here's an example of that. Here's some screen grabs from emails that I get. I'm set up to get some of these alerts. So in this case, we lost a contact to a controller, 146 southbound to Twin River Road, 7:34 a.m. on a Monday. And then at 8:25 a.m. on the same Monday, it says BlinkLink resolved the event. So what happened here, I'm guessing here, but I'm pretty sure it wasn't a case where our maintenance personnel went out and changed something. This was a case with I mentioned before, the batteries and the solar power. We had lost power thanks to it being January and lack of sun. We probably lost power for a while, but then the system was able to recharge and it came back online on its own. The final thing from system reporting is this is a example of data you can get from BlinkLink. You can download reports, and I did that. What I was doing here is looking at number of low voltage alerts and where they're occurring. Well, in this case, you can see all our systems there on the left. Look at the 98 at this one location, Twin River Road from 146 southbound. Clearly, that is a flag to me that there's some type of a power issue there, and so we can look at that further, and we are. The final screen grab I wanted to show before I get ready to wrap up is this is a case where system did its job, the person was reported, but this is good and bad. The good is the notes. Look at the note here. The person typed in, Rhode Island State Police pulled this person over on I-195, 95 southbound merge. That's a mile and a half from here. That's disconcerting. The good news is it was resolved correctly. The person continued wrong way. And we have the image of the vehicle. We have the alerts that were made. The system's working great. The scary part, as I mentioned, is the fact that they went the wrong way. So I'm mentioning this because the system isn't a panacea, right? Any traffic safety on the line right now knows that impaired drivers, drunk drivers, things like that, it's just distractions. It's a reality that we have to deal with for the time being. So with that, I want to show you the protocol that we use to try to help on that end. And I know I'm rushing here. I apologize, guys, but basically you can see this is a quick protocol of how we handle these alerts when we get them. So the email or the text alert is received. If BlinkLink is open, it's over on the right. You can see the screen grab of, it's an image of our workstation that we have in our TMC. It's an isolated workstation where we keep BlinkLink open 24/7. And there's an audible alert in there, which is pretty cool. It's pretty annoying, which I like. It tells you that there's an alert received. The TMC and police will get that. And then in our TMC, which there it is, you can see the image. The next job for the TMC is to try to verify, is it a wrong way driver? Was it a false positive? Okay. If not, did they self-correct? If not, okay. Well, then now we have a real problem, a real high risk. And so we look at the BlinkLink photos that I showed before. BlinkLink, TAPCO does offer video. I mentioned the newer cameras now. They'll offer streaming video for you, I believe. We don't use that yet. But that option is there. We also use our own traditional TMC cameras, traffic monitoring cameras that we have around our freeways. There are gaps there, but we do use those if available to try to verify. And then while that's happening, really, we're coordinating with the police. By now, usually a call is made one way or the other. Usually, I shouldn't say usually, sorry. Sometimes the police will call us to make sure we're aware of something. I mean, we're staffed 24/7 with operators in our TMC in Providence. As are the police. They have local dispatch and stuff, but it's a multi-person team, I should say, with coordinating it and trying to stay on top of this. Things are happening lightning fast, and so it makes it a challenge. But we're trying to monitor what's going on, and then finally, if verified as appropriate, the police can dispatch, right, to try to cut off a wrong way vehicle or stop that person in a safe way. God bless them, honestly. That's a risky job to do, and I just am so indebted to police and first responders for what they do. The other side is the TMC. We can post messages on our changeable message signs, as I mentioned before, to right-way drivers. And that's if we have one available and if it's easy to do. Keynote for you guys, so as of today, we still haven't yet posted any such messages. And there's reasons for that. I'm going to blast through this. I gave a presentation earlier in the year on traveler information challenges. And this is one for us anyways, because we've drafted some messages at the top right that you might use for this. However, people like me are sticklers with the METCD, and the METCD itself says that you're supposed to, make sure any messages you post for the public is concise, timely, and accurate, And so if a wrong way driver is detected, it already takes seconds to know where they are. It can be a challenge for us to post signs. And so we're having internal discussions at RIDOT right now on why haven't we done this yet? We're really strongly considering doing it because we believe we should. It's probably the right thing to do. We just want to get our messages right. But at this point, I want to share. I think I saw some people on the call register to attend today from Michigan and Florida, Arizona. Other states have done much more than we have here on this. Michigan has a great, you can see their example message there on the right. They have a great video. They produce a nice video with law enforcement and everything, showing how they react and what people need to do to avoid wrong way drivers. The Arizona website at the bottom is one of the best examples I found anyways of what you want to tell the public on how do I handle a wrong way driver on the freeway. Can anybody here tell me that you can fit all that information in that bottom box into the CMS message? The answer is no. You just can't fit all that on a changeable message sign. So this has been a challenge for us. I wanted to share it. Real quickly, cost and maintenance, in case you were curious. Some of these numbers are dated, but we saved some money originally in 2014, 15 with doing so many at one time. The systems were as low as 25 grand a location, roughly, for a two post system. More recently, some of the systems have been up to about 100,000 per location. 2 or 4 poles, all types of training in there, cell modems, web service, all that stuff has to be included. So I would just recommend the cost on this. You look at your potential suppliers for if you're looking for up-to-date costs. These costs are a little bit dated. But the other key thing I wanted to show was for maintenance and agreements here, we currently have we just re-upped a contract with TAPCO to provide maintenance at our systems. I would say, thankfully, we do preventative maintenance quarterly. And one of those quarterly maintenances includes a test and a recertification. That's done once a year. I applaud our officials at the top of the DOT here saying that, hey, we treat this as kind of almost like a life safety system, even though it's not a required system, right? It's a life safety related system. So we've put a high priority on maintenance, which I love seeing as an engineer. We often don't see that for ITS. Usually O&M and operations and maintenance is the last thing that gets prioritized, which bothers me. But in this case, RIDOT, I think, is doing a great job with TAPCO's help to maintain our systems. And again, we've used mostly Highway Safety Improvement Program funding for this. So lastly, I'll finish with the promising future. So we do have detection upgrades to make at our false positive locations. We're completing that now. We do have some system expansion planned. I asked our state traffic engineer what his plans were, and he shared that, he said, if we have any new locations with substandard geometry or maybe 2 on-off ramps are right next to each other, those locations would probably certainly warrant a new system. So certain higher risk locations, we're looking at that. From the TMC side where I work, we are looking at integrating the procedures into our ATMS. We're now talking about trying to get ready to procure one of those when the time's right. Even before that, we're updating our operator processes. You can see the manual on the right to make sure we get better consistency on how our operators are resolving the issues and taking action to try to curb the problems. So longer term, this is the stuff that gets me really excited, is some of you on the line, especially from Florida, there's many out there in academia and DOTs who are way more advanced than I am on this, but the technology is there today, I believe, to provide direct alerts inside the vehicle, whether it's via mobile phone, text alerts, CV integration with onboard units and things. The tech is there. The problem is there's some societal is not the right word. There's some issues with safety risk issues with having people look at their phones, right? But it's a lot of people use phones now that are docked in their car and things like that. So it's one of those areas that's really encouraging, it's exciting, but long term, I believe it's going to be the integration into the car. And why rely on a roadside sign if the in-car notice can do the job, right? You'd say. So this RIDOT's aware of, we just haven't advanced it yet here. And even better is I love this stuff, to control the vehicle. This is real future stuff. There's societal issues and legal issues with this, but I mean, again, if what's the problem? Engineers say solve the problem. If there's an impaired driver who's drunk on the road, that vehicle should not be allowed to move, and so there's some promising stuff on this, interlocks and stuff, but there's still some things to be worked out. So I applaud any of your states who are studying it. A lot of academia is studying this, and DOTs. It's small steps to get there. So I appreciate what others are doing on that. Last slide I have, and then I want to let Nick speak. I've talked a lot, sorry, Nick, but basically, remember the original slide, I showed the challenges we had. So I hope I've shown that there are most of these challenges, an intelligent wrong way system can help you meet that challenge. older, distracted, impaired drivers. Even if that person that Christmas night, wrong way I showed you, he or she turned around. Probably coming from a bar. I don't know if they were intoxicated over the legal limit, 08, but maybe they were slightly. And so the flashing signs just themselves seem to be helping. And then the second bullet, third bullet, pour anywhere, anytime. Geometric improvement's not feasible. You can't put a barrier in, but that's where I think the TAPCO systems like TAPCO's can help. You can put it in an existing location with poor geometry, and the system can do its job. Finally, the violations not being documented at the bottom. Like I think I showed several cases where it's great. These systems give you data. They'll give you a record of what's happening, so you can better understand how you want to try to meet the challenge. That said, I've highlighted in orange the three things I think that CAV and automated driving assistance systems offer the most promise. So even if you put TAPCO systems everywhere, there's still I showed you that 11%, right? Those folks who are getting through. That's where we need to push the envelope with CAVs and in-vehicle controls and things. And as I mentioned last slide, that's really exciting and encouraging. So that's what I had. Thanks for your time, and sorry I spoke so fast.
Awesome. Yeah, thank you, Russ. Can everyone hear me? This is Nick. Can you hear me, Marissa?
I can hear you, Nick.
Awesome.
Yes, I can hear you. Sorry.
All right, I'll just get to my slides here. So Russ gave a great overview of their deployment. So what I'll be talking about here is just a little bit additional background about TAPCO, who we are, our expertise, and I'll give a little bit more insight about BlinkLink, right? You can see that throughout Russ's conversation and information there, a lot of references of data, right? And there's only so many ways you can capture data, especially with these types of events. So just real quick, brief history on TAPCO. We've been around for 65 years. We're family owned. We've been driving innovation for all 65 years. We brought the wrong way alert system to market in 2011. We added BlinkLink to the system in 2014. We first started with those LED enhanced signs that you guys, I'm sure, are well aware of in the industry. And we kept hearing questions and requests. I want to see who is actually triggering these systems. I want to see if they actually self-corrected, right? All the information that Russ mentioned today, that was really the prelude to our BlinkLink event management software, which will be the focus of my conversation coming up here. A sobering, I guess pun intended here, fact, across our systems in 2020, we detected 552 wrong way drivers. So if you just think about the magnitude of our reach of the ecosystem that we have, RIDOT, including many other states where they have TAPCO wrong way alert systems, we detected 552 instances of a wrong way driver, right? We're seeing about an 85 and some locations up to 98% self-correction rate. So if you just think about the amount of drivers that still slip through, it's very much a problem, that hence the reason we're talking about it here today, and we'll continue to talk about it into the foreseeable future. So an interesting update about VMT, right? VMT is something that engineers in the industry like to look at in terms of how often are these events occurring. So I think we're all aware of what happened in 2020 with the wonderful global pandemic, right? And we saw that initial drop off, and you can see that picture there in the VMT, vehicles miles traveled, right? But what we're seeing is improvement, or an increase, excuse me, of vehicle miles traveled as of late. So we're seeing the bottom. We've reached the bottom. We bottomed out. And we're seeing more and more civilians head back to work, get back on the roads, and we're seeing the numbers get back to, well, albeit not the previous levels, in 2019, we're starting to come back to some levels around October of 2015. So just know that, hey, if we had a decrease in wrong way events for some time because there's less motorists on the road, that trend is turning around and going back in the previous direction. Let's see here. Now, the gloomy part of the conversation relative to VMT is that traffic fatalities are expected to surpass 45,000 fatalities in 2021. So even though we're still down in terms of VMT, motorists on the roadway, we're seeing a significant increase in uptick in fatalities, right? The number of fatalities have been recognized as a crisis, and that's by NHTSA and the FHWA. So we're still about 30%, 40% down in terms of people on the roadway. Nonetheless, our fatalities have, in this sense, skyrocketed in the last 2 years. So, what is going on? What are the issues? One of the issues that we're obviously focusing on here today is wrong way driving. So, there's obviously been some recent involvement and analysis of some of these fatalities, why they're occurring. Less motorists on the road, more opportunity for speed. There's an uptick in stress, anger in society. distraction, right? Here I am presenting at my cell phone next to me. What is it like inside of a vehicle, right? Oftentimes you'll look over and you'll see, unfortunately, a motorist on their cell phone. And then the crux of wrong way driving oftentimes comes back to impairment. So while only 3.7% of traffic fatalities are associated to wrong way driving, they make up a large majority of the fatalities, and that is because they're so severe, as Russell mentioned. So an unfortunate fact of wrong way driving is that 60% of the drivers going the wrong way in fatal crashes had a BAC greater than 0.08, right? So impairment is very front and center in terms of this issue, this crisis. Let's talk about connectivity and how we can progress and use the data, like I just mentioned here, and the data that we're collecting in BlinkLink to really define our future. So at the crux of ITS, right, that's what we're talking about here is intelligent transportation systems, technologies to detect different types of scenarios and events. At the crux of an ITS system is sensors and networks, right? Oftentimes connected networks, networks where you can remotely access your equipment. This is vital and key to an ITS smart city deployment. Being able to monitor your traffic, identify safety concerns. So we're talking about here with wrong way, coordinate intervention involving law enforcement, involving DOT officials, responding to different events that happen on the roadways when fatalities or incidents occur. Confirming that the investments that you've budgeted and deployed in your region or district are up and operational, right? One of the worst things that you can do is deploy a system that you can't remotely monitor and understand if it is operational and ready to go for those circumstances. And the last bullet there, collecting data, right? Data, cliche statement, more valuable than oil, only if it's actionable. Data is recognized as the most critical asset in justifying and allocating state and federal funding. I'm sure I'm, preaching to the choir here in terms of, your processes of receiving funding, right? You have to bring data, information to those parties that are allocating the funding. So it is at the crux of all of these assessments that must be had on the front end of a development is understanding where we're deploying these technologies, what is the severity of the issue that we're trying to solve, and most importantly, when we deploy the ITS equipment, did it do its job? So one of the ways to really back into that last statement there of quantifying the system's effectiveness is leveraging the BlinkLink event management software. Russell gave you good insight as to what that platform looks like. As far as what it is, it's a proprietary software we developed here at TAPCO. It's cloud-based. You can access it on your computer, your cell phone, tablet, any web-enabled device. It's our principal interface for all of our systems, pedestrian, overheight, wrong way, flood, etc. And what it does is it connects remote systems to localized users, right? It's your ability to monitor your systems from a remote vantage point. So what it's used for, it's multifaceted. The first value of the BlinkLink event management software is management. Being able to manage a single system, or in Russ's case, 29 systems, right? Well, Russ has 29 wrong way systems in RIDOT. Let's say RIDOT also has pedestrian crosswalk systems, school zone beacon systems, right? Now BlinkLink can be used not only manage your wrong way technologies, but an extensive list of ITS applications. It also allows and controls access to the information that viewers may access in the platform. So you may only want certain viewers, such as a system director, to see certain types of detail and information. Maybe the operations manager who's living within the day-to-day management of the system, they'll have a different credentialed access, right? They can only see certain information. And like Russ mentioned, the low priority alerts, the low voltage, the contact controller, the communication alerts, that's great for the maintenance manager. You don't need that information going to the system director or to operations. That type of information can be allocated for those parties that are responsible for the maintenance of the system. So it's a nice way to delineate and separate information and where it goes. It's also used for maintaining alerts and responding to events according to your processes and procedures. So we provide the platform for providing information to you, the end user, and you have to, on your side, develop a process and procedure to respond to the information, right? So when we see this type of scenario or event, we respond in this manner. When we see this type of information or that type of information, we respond in that manner, right? All of this comes down to managing the systems and the information that's presented. And then you can also manage the system status, right? Is it operational? Is it online? And I'll touch on that a little bit more coming up here. The scheduling function, I'll be brief here. This is really for the pedestrian scenarios or the school zone beacon systems. your ability to actually schedule the system when it's operational. So scheduling both, hey, it's on from 7 to 8 when I'm dropping children off at the school, or 3 to 4 when parents are picking them up. Or you can do manual flash activation and deactivation. Hey, we have a non-standard event. We have some kind of, let's say, football game or some kind of gathering. We want the system operational, right? You can manually control that. So it's a nice function that's, like I said, generally associated with the pedestrian type application. For wrong way, in this instance, we always want the system ready to go and operational. We detect something, we sense it, and then we trigger those signs. So for that instance and application, we do not leverage and utilize the scheduling function of BlinkLink. Next, probably one of the most valuable parts is identifying what the system is seeing, right? So we're talking about wrong way. The sensors that are used in the wrong way application are designed and calibrated for wrong way vehicle detection and movement. You can see the picture there to the right is our flood system in operation, right? This is actually in Sea Isle where the roadway regularly floods. So we have an alternative sensor that's designed for detection of flood, right? So the systems are pre-configured leaving TAPCO going into your field in your district, your region, according to the application. And when that sensor or that system detects that certain environment, that's when we're transmitting and relaying imagery. So, standard images, video, and streaming. And I'll touch on that coming up more here. Really, the next step here is the TMC or their operations team responding to this information, identifying threats and safety risks. Hey, my road is flooded. Do I need to close that roadway? Hey, we have a wrong way continuation. Do we need to push messaging to right way motorists on DMS boards? Or do we need to send out law enforcement to go intercept that continuation, right? So all of that is achieved with visual insights from the system. And then we're logging all this information, logging both the event details according to that behavior and also the system health, right? So down below, it's kind of hard to see. We have different metrics and diagnostics that we're tracking to see proactively if there's a system issue that needs to be resolved. Rather than wait until a civilian tells you that your system's down or offline, what better way to proactively address it than have some key metrics that you can review on a regular basis of the health of your system or your investment. Allocating and prioritizing resources, right? So first we'll talk about safety. So in terms of wrong way, hey, we have a continuation. We need to include or relay the information to law enforcement, right? So dispatch will get involved and relay that information of a continuation. At the Traffic Management Center, what they'll be tasked with doing is resolving the events. You can see that pictured here on the right. They'll select the proper resolution that coincides with the event details that we're seeing and visualize, put some notes as to what they saw. Hey, wrong way driver was in the left lane. Hey, wrong way driver self-corrected. Looks like it was a red sedan that was, the offender in this instance. Any notes, right? So that's kind of your safety approach in terms of allocating and prioritizing resources corresponding to events. But then there's the maintenance aspect, and we already touched on that, so I won't dive in that too deeply again. But nonetheless, hey, you have an alert regarding your system health. We need to dispatch and allocate the maintenance team to go investigate what may be happening at that system. All of that is achieved with the remote access of BlinkLink event management software. Probably one of the most important, if not the most important part of the BlinkLink software and platform is collecting data. Russell showed you that their effectiveness, their reduction in fatalities, the time of the events, the self-correction rates, all of that information and data was achieved by pulling reports from BlinkLink, right? So one of the greatest parts about the information, you can use it for confirmation that your current investment has achieved its goal and reporting back to your subordinates about those results, but then also using that information to justify additional investments, right? Hey, we've had 85, 98% effectiveness at these locations. I'm requesting funding at these 3 additional locations. So all this information is a continuous value chain that can be used from the current systems to future deployments. And that's really one of the greatest benefits of collecting data remotely. As I mentioned, the BlinkLink supports many applications, all the way from a simple blinker sign, LED enhanced sign. So here we're showing the pedestrian W11-2, RFB crosswalks, school zone, as I mentioned, flood, overheight, wrong way, right? So BlinkLink isn't just used for wrong way. I want to be very clear on that. BlinkLink is used for the management of all ITS relative to our TAPCO technologies systems that you can manage remotely. So something to be very aware of, right? So when you invest in BlinkLink for wrong way, well, how else can I use BlinkLink, that same platform, for other safety issues in my district or region? Something to be aware of when you're deploying the platform. Russ did show this. He did tell you and display that RIDOT opted in for option 1. That's our traditional architecture where we provide the TAPCO modem. As I mentioned in the comments, it's a Verizon network. Now, option 2 and option 3, we've been able to provide to end users such as yourself in the last 2 years here with the release of our new advanced communication controller. Option 2, really what that is a customer or agency saying, hey, we have our local fiber network, or we have our own cellular modem that we'd like to use. Let's say you guys have your own cellular modem you use across the state for a wide variety of different applications. You may have purchasing power, economies of scale by using that cellular modem. Great, we can still offer BlinkLink with option 2. You provide the network, albeit we have to use an open VPN. So you still get the value of BlinkLink. You are just providing the network. And then option 3 is if you do have a statewide ATMS. There are certain states such as Florida, Texas, Wisconsin, here where TAPCO resides, that have a statewide ATMS platform. And in those instances, sometimes the customer may say, we don't necessarily need BlinkLink. We have our ATMS software. We want to use that. Can you communicate with your local system to our platform? Yes, we can. We call that the direct to ATMS. So option 3, the takeaway here is that you guys have to have an existing ATMS, and then that the BlinkLink features and value falls off. So all of the data, all of the images presented in BlinkLink, all of that information I just showed you do fall off with this configuration here. So that is something to be considerate of if you do proceed that path. Also, we are able to offer an API connection between BlinkLink and an ATMS. So there's many states. This is actually the case in Wisconsin and Florida. We're actually discussing this in a couple other states as well currently, where they have an ATMS, but there's certain features and benefits of the BlinkLink that are just not provided by the ATMS platform. So in that instance, they're still opting in for a BlinkLink connection, and we're just having a bridge or the API to facilitate that connection to the ATMS. So now there's a streamlined automated process, right? You can resolve the event in your ATMS platform and it'll kick back to BlinkLink. You can put additional notes in BlinkLink. You can do all your data mining in BlinkLink. So it's a great way to bridge 2 platforms and use them in unison and one cohesive deployment. So do note that if you do have an ATMS platform, we can bridge a connection with an API. We have a document that's ready to go, very clear as to how you make that integration. So super exciting new capability that we've been able to offer in the last couple of years here. I would be remiss to not mention our subscription options for BlinkLink. There's really 4 primary subscription options, and it really oftentimes depends on the type of system you have and the type of information you're trying to collect. So the first one there is your simplistic system. Let's just say you have a blinker sign or an RFB crosswalk, right? You're looking for the health and monitoring of the system, your diagnostics, your reporting, and your scheduling function. Okay, that's called the BlinkLink subscription, right? The next one is the BlinkLink alerting. You can see the addition there is high priority alerting. What does that mean? Well, as Russ mentioned, that's your email, your text, your pop-ups in the BlinkLink platform. It's, hey, here's something was detected or sensed by the system, and we're alerting you, right? So the next step or differentiator here is just we're providing alerting. Take it one step further, BlinkLink Alert Premium. In that alert, we're providing imagery. So between the previous column and this column, now we're providing imagery, right? So here's some still images if you have those access visual cameras with our system to confirm what the system saw. So that's your main differentiator there. And then new to our offering in this in the last really 3 months here is video and streaming. We call this the new Enhanced BlinkLink. So really what we're doing here is we're providing high priority alerts with standard imagery and now video and streaming. And I'll touch on what the capabilities of video and streaming are. So the subscription packages vary based on the network type. So option 1 or 2, as previously displayed, how many systems you have, how long of a contract are you seeking, and then obviously the type of value you're looking for from BlinkLink in one of these 4 options listed above here. So as I mentioned, the 3 new options we're able to offer with BlinkLink, the Enhanced BlinkLink is immediate event streaming. So now when there's an alert pop up in BlinkLink, now you can dive locally into that system and watch a live stream of that event. So let's talk about wrong way. Why would I want to watch a live stream? Well, now the operator at the TMC can view with his or her own eyes the actual unfolding of that event. Traditionally, there'd only be about 15 images. Now with the immediate event streaming, you can watch and continue to watch how that motorist responded to those LED signs. Next is a downloadable event video. This is good for after action analysis. So this is good. Hey, once a month, once a quarter, once a year, we compile all the information and we review it with our team as a collective, right? What did we see? What were our self-correction rates? When we saw continuations, how did they continue? Were they going fast? Did they pause? All those details are afforded with downloadable event video. So it's a 2-minute video. You can download it and store it accordingly on your platform. If you do not download the video, we just overwrite it within BlinkLink in 45 days. So you have a 45-day window to access and download that video and store it as you see fit. Otherwise, we'll overwrite it and it'll go into oblivion and disappear. And last is on-demand streaming. This is for, hey, we have cameras on the side of the road with these systems. Sorry, here I'm getting beeping on my side. We have cameras on the side of the road. Why not offer the users the ability to live stream and to view what may be happening in the vicinity of that system? So a great example is a customer in a southern state had a wrong-way system on one of the ramps. There was an accident on the main line. They wanted to use the local system that had those visual cameras to confirm that motorists were indeed exiting the main line at that ramp. A great byproduct of having cameras on the side of the roadway and the on-demand streaming function. This is my last slide here, and then we'll open it up for some questions. So one of the things that I'd be remiss to mention here to summarize our conversation here today, and Russ, like he mentioned, RIDOT recently opted into this. When you invest in these systems, it's not just an initial investment that you need to be focused on, right? It's the longevity of the system, the lifespan of the system. There is service involved with these systems, just like there's service involved when you buy a brand new car, right? So the same applies here for ITS technologies. A nice byproduct of opting in for a TAPCO provided service solution is that you get discounted BlinkLink event management software. You also obviously get all the benefits of our service package detailed here. And then you also get an extended warranty. So if you opt in for a 5-year or 10-year service program, annual service, right, we do preventive maintenance, you would have warranty through that 6th or that 11th year. So really, this is an economy of scale option for you as a deploying agency. Hey, we want to buy the system. Hey, we want to buy BlinkLink. And hey, we want to opt in for regular preventive maintenance to make sure that our investment is sustainable for the life of the system. And that's achieved with that holistic approach and mindset. So with that, I'll open it up for questions. I know I answered some of the questions here in the chat myself, but we do have some time here, about 5 or 10 minutes for any additional questions that the audience may have. And the last thing I'll mention is we will be sending out the presentation to the attendees here. So if there's anything that we glossed over quickly or any additional information you'd like to pull from today's conversation, it will be made available to you and your team.
All right, Nick. So I have just a couple questions here. Forgive me if you've already answered these, but I don't think you did. So the first question for either you or Russ, a large portion of wrong-way driver incidents happen in metro areas. Is that perhaps due to more cameras and police officers? And then another question was, how are these deployment sites selected?
Yeah, let me take the first one there, Russ.
We
and
did
I think
have
you
one
can
more
maybe glean
question
us
come
as
in
to what
from David.
RIDOT, how you determine your site
Sure.
selection. So the first question there, do the events follow population? Yes, they do. There's a study done by Florida DOT that found that 76% of wrong-way events occur in an urbanized setting, where the remaining 24 occurred in a rural setting, right? And I don't think that's surprising to understand that, wrong-way events and movements follow where populations are dense, right? So that's just a byproduct of this behavior. So great question.
Yeah, thanks, Nick. And I'll just add the second part of the question, if I understood it right, was how do you select where to put them? As I showed it earlier in my presentation, it's kind of a risk. You're trying to minimize risk, basically. And if you had unlimited funds and unlimited resources, then you put them everywhere, you might say. But obviously, nobody does. You've got to decide where to prioritize such things. So like I said, for Rhode Island's case anyways, for our pilot, we did coordination with state police, who has the most experience with knowing where they're giving tickets, where they're seeing problems, and then also looking at our crash data, where the actual crashes occur and which ramps did people use to go the wrong way. We looked at all that and then decided where to prioritize the systems. So in the end, there's no black or white on that. There's no rule on it. I would just argue you should probably be data driven where you can to minimize your risks. Yep.
How do we run reports similar to the ones seen at the beginning of the presentation, showing multiple systems?
Yeah, great question, David. You know, I have a training piece that I can provide to you and your team as to how to pull the reports. There's a nice function in BlinkLink that details up above in the taskbar report. And from there, you can, you know, go back 7 days. You can go back up to 90 days. You can create a custom window in which you'd like to review all the activations from your system. And that information will be kicked into an Excel CSV file that can be pivot tabled, et cetera, into different slices and dices of information. So would love to provide you and your team with some additional training. So I'll reach out to you offline, and then hopefully we can get you an answer and show your team how to pull those wonderful reports. Awesome.
For all of the questions. Again, we will be sending out this presentation with Nick and Russ's contact information, hopefully this week. So we will get this sent out. There are a couple people asking about PDH. I will look into that as well and get back to everyone. So with that being said, thank you so much, everyone. Have an amazing rest of your day. Thank you, Nick. Thank you, Russ. And yeah, everyone have a nice rest of your week.
Thank you. You too. Thank you.
Thank you.